We live? Okay, sweet. Morning. Welcome, everybody. Thank you for getting up nice and early. I know it's day 2, but we have some cool stuff to show you. Today we're going to talk about the brand new BlackBerry 10 browser. We're very excited about this. First of all, it's a web app. This is, woo! See this? Oohs, ahs. This is actually really important. We're going to talk about this because this is really what helped us to advance all of our technology to the point that it is right now. We good? So we're going to take a look at a whole bunch of screenshots. We have some demos. We're going to go through, sort of run through the browser, show you some of the new functionality that we have in it, a little bit more than we had time to do on the keynote. We'll show you how we implemented some of these things. They look like Cascades type of widgets, but they're all implemented in web. We'll go inside and show you how it's actually built from a code level to understand how the different components go together, how they're reused, how we quote-unquote compile the application, that kind of stuff. So you can see how we built such a complicated web app on top of what we're calling the web platform. We'll talk about current limitations. There are some limitations in web in general, just some things that are a little bit harder to do that might be in a native programming language. We'll talk about development tools. Am I in your way, Eduardo, when I'm walking here? No? And we'll talk about some lessons learned and some of the cool stuff that's to come down our roadmap. So you guys got a first look at this yesterday. How many of you have devices? How many of you have gotten a chance to play with the browser? Okay, cool. So here you can see we have our tab menu. Again, this implements the peak aspect of BB10, or BlackBerry 10, which you're going to see sort of everywhere across the entire platform. Just really makes things easy to access no matter where you are in the browser. The main screen, overflow menu, options, application menu. Switch to the demo. Can we switch over to the demo? So let's take a live look at the browser and show off some of the new functionality. So here you see we have the home screen, and we're really focused on making content be king. So not trying to get in the way of the user, but making it really easy for users to get directly to the content that they want to get to and to consume that content or act on that content in some way. So in this case, you can see we have a bunch of bookmarks in history. And these get updated and sorted depending on the frequency of use. Or you can go and enter a URL. Do you want to go somewhere? So you can see, just like Cascades, we've implemented the ability to shift web content around when the virtual keyboard comes up. Okay.
Whoa. Cool.
That's the checkerboard.
There's a little bit of weirdness with HDMI out.
Okay. So you can see again, this is our main area. Did you lose that tab?
No, I just closed it.
Open up another tab. You want to open up a few tabs, actually?
Woohoo. Let's try that again.
Does it look as weird on your screen, Eli? And that's because it's connected to HDMI?
I'm going to say yes. There you go.
All right. So you can see even like the animations that we have are really smooth. When he selected a bookmark, it had this fade-in animation. Again, this is all implemented just in CSS and JavaScript, and we'll show you some examples of that a bit later on. Let's talk about some of the new features we have. So we have sort of a split bookmarks history view. You can slide back and forth. And I did see a lot of comments yesterday online, actually, as to whether or not we have the ability to sort bookmarks. So, yeah. We haven't added in a direct functionality to be able to place them manually. But what we have done is added filtering, so you can search. And we've added tagging, so you can tag your bookmarks. Do you want to show an example of that, Eli?
Sure.
We just think this is a little bit more interesting of an interface rather than having to try to implement some sort of drag and drop mechanism that doesn't really work very well on mobile devices. Most of the time, users, what we found, don't necessarily even go into their bookmarks and want to click on them directly. They'll start typing in the URL bar. And in our URL bar, we do search, which does pull in your history, does pull in your bookmarks. So those will get pulled in automatically. And it's actually much quicker than having to go through and manually hit things.
Good.
So for any bookmark you have, you can go and edit the bookmark. You can add tags, which will get added. And then you can switch to the tag view, and you can do searching, and it will search through all of the bookmarks that have the tags, and we'll show them in a listed order, and you can access them really quickly. Pretty cool. Want to go to options? So we have some new features in terms of options as well. One of the ones that I think is particularly interesting is private browsing mode. I don't know if many of you have used it before, but we've re-implemented private browsing mode in a slightly different way now. It operates a little bit more like a desktop browser might, where if you switch to private browsing mode, it will save out your entire session. All of your tabs will get saved out, closed. It will open a new session with a brand new tab, which is in private browsing mode. And then when you switch back, afterwards it will restore your session so you end up exactly where you left off. So in that case, there's no confusion as to, is this tab in private browsing mode or is it in regular browsing mode? There's no cross-contamination there. Okay. Should we move on from here?
Sure.
Can we switch back? So I think one of the questions that a lot of people have been asking is, why web? Why did we choose to implement this in web technology rather than using Cascades or some other native technology? I think there are 3 reasons for this. One being that we want to be the leaders in HTML5 standard support. 2, we want to be the best in terms of performance in those implementations. And 3, we really want to make sure that we understand the developer community and can provide the best tooling and the best developer experience for developing web technologies on BlackBerry. And the only way that we could really do this is by diving in and building something really complex in web ourselves. We hadn't really done it before. So it was difficult for us to really understand how that process was. And we learned a lot. There were a lot of problems that we had to go through when we were building the browser. And we were able to take those experiences, improve not only on the process, but on the technology as well, so that now it's significantly easier to implement the same things that we implemented for the browser. So we'll talk a little bit about some of those things as we go down. So how do we do it? This is basically the way the stack looks to build the browser. On the bottom, we have the BlackBerry 10 OS, Unix, which provides sort of the lower level functionality, networking, device APIs. On top of that, we have the WebKit rendering engine, which we've been updating, which includes most of the new HTML5 functionality. And then we had our browser application. We couldn't really build it right on top because we had to provide some sort of way to communicate back and forth between native. And that's where the web platform comes in. And it's basically a framework for running web code. And I'll talk a little bit more about that in detail in a moment. And on top of that sits the browser application, which is 100% pure JavaScript, HTML, and CSS. So what is the web platform? The web platform is a framework for building web applications. It's the basis for WebWorks, it's the basis for QNX Car, and it's the basis for the web browser. It provides a multi-process launcher, which is new. We now have the ability to launch Webviews either in process or out of process. And we utilize this in the browser for very specific things, like making sure that if a browser tab does crash, it will not, to make it not bring down the entire application. So we have the ability to crash tabs gracefully and even restore them. It provides management of web views. So you can have one web view spawn another web view, manipulate the geometry of the web view, the opacity of the web view, call Webview APIs on it, or even load data into the web view. It provides native API access from JavaScript. So we have bindings for pretty much all of our low-level functionality from JavaScript to native. For example, PPS, sharing framework, invocation framework, and many others. And we provide some core BlackBerry 10 UI elements, like the crosscut menu, application menu. So these things can automatically be used by apps, for instance, that are built in WebWorks. Talk about this. So Eli's going to come up, and he's going to give you a little bit more in-depth view into what we mean by a Webview in BB10.
Thanks, Matthew. So the Webview is probably the most important API for people who are building this type of web application. The Webview itself is essentially an independent web content container. You can think of it kind of like a browser tab. We have two different main types of web views. We have what we call the Chrome web views or privileged web views. These are used in the browser application to draw the actual browser Chrome, so the navigation bar at the bottom and the tab switcher, those are Chrome web views. They have some special access. So in particular, they have access to the Webview API. So the Chrome web views can manage other web views. They have a native API plugin that gives them access to the native APIs that Matthew talked about, PPS, and the invocation framework, and the sharing framework, and so on. And they relax some of the constraints of the standard web runtime. So in particular, it allows you to unsandbox the file system API. If you've used the HTML5 file system API, you know that that's restricted to a sandbox inside your application. Well, we allow you to use the same API from a Chrome web view to access the actual file system. It's just a nice API that allows you to use things that are familiar to web developers, but get access to the underlying device. And then there are content web views. Content web views are actual browser tabs. They're optimized for loading third-party drive-by, drive-by internet content, drive-by World Wide Web content. So they don't relax any of the security constraints because this is content that we don't trust. But they have a large backing store that allows us to pre-render content so that scrolling and zooming and that sort of thing is very fast. That's much less important for a Chrome web view where typically your content doesn't scroll that much or zoom at all. It also has a disk cache and some other networking optimizations. The Chrome web views don't tend to do a lot of network activity, and in particular, the network activity that they do is not cacheable. So that isn't important for the Chrome web views. The content web views, of course, the disk cache gets you lots of gains. So I think you've probably seen this slide before because Laurent stole it, but this is my slide. This is a picture of the browser, and just like you saw in the demo before, here's what happens when you slide from the navigation bar to the side to reveal the tab switcher. And what is actually happening behind the scenes here is that there's a number of web views on screen at the same time, some Chrome web views and some content web views that make up this whole experience. So if I blow this up a little bit, you can see that here are some browser tabs. Those browser tabs are content. They're running out of process. So those are sandboxed out of the privileged Chrome process. And then the Chrome itself is made up out of a number of web views. Here I'm showing 4 of them. There's actually a couple more. And on the left, we have the tab switcher. On the bottom, we have the navigation bar. On the top, we have the application menu. And on the right there, we have the Chrome web view. This is the main Chrome web view. In this case, it's showing you the title bar. But when we do things like pop up dialogues or bring in the crosscut menu, that also happens in that web view. The reason that we've put these into separate web views is mostly for performance. Some of the transitions that they do are somewhat difficult to do using standard CSS transitions or showing a web view on top of web content. If you have to blend those web views together, it's somewhat expensive. Whereas if we just have the navigation bar at the bottom that doesn't actually extend over top of the content, it's much cheaper. It uses less battery and that sort of thing because we don't have to run the compositor that much. As Matthew said, we have web versions of the BlackBerry 10 UI elements that we use. So everything you've seen there is re-implemented in HTML, JavaScript, and CSS. We use also a fair amount of images, so the native assets that come from Cascades are also reused in the web platform. And we use CSS transitions very heavily. So for things that are not multiple web views synchronized together, everything is done using CSS transitions. And that allows us to use standard web techniques to get hardware accelerated transitions. We can get 60 frames per second, and everything works quite well. So as I said, there's a couple cases where we use window animations to do things that CSS transitions can't do for us. So here's some examples of some of the native UI components. We have dialogues. You can see on the left, that's the site information dialog. So that shows you like the security information about the site that you're on. Then there's the settings page that you saw. This looks pixel for pixel, exactly like a Cascades list. And then you can see the display and actions settings page. So this comes in on top of the settings page. And you can see there's a combo box and some of those toggle buttons. You may have been seeing when I did the demo that the toggle buttons have the little halo that comes out when you touch them and has all of the nice features of the Cascades controls. And on the right, you see the crosscut menu. So the crosscut menu, you saw it comes in just with the icons, and then you can pull it out and get the full list. In this particular case, I've long pressed on a link, so it gives you context-specific options. So you can see the link information at the top. That's the text of the link and the URL of the link. You have a copy link and share link and all of that sort of thing. Did you want to show a demo of that?
Sharing link?
Switch back to the HDMI.
Of share?
Yes. So keeping with the BlackBerry 10 themes of peak and flow, we try to make sure that you can stay inside the application and still collaborate with other people and share information from the web. So here, Matthew's long pressed on one of his bookmarks and then picked share link from the crosscut menu. And this is the share target selector. This device has a few share targets set up, so here he's going to share it with Twitter. And you can see now we've brought in the Twitter share card, and we can peek back to the browser, and then we can flow into the share card and tweet the link that we're on.
That's cool because that's two different technologies. That's Cascades peeking on top with the web technology underneath.
Right. The browser, the share target selector is web, but the actual Twitter card is Cascades.
So your web applications can seamlessly integrate with Cascades.
Okay, can we go back to the slides? So some of these controls have already been packaged up as part of WebWorks, and we're working on doing a lot more of them. Part of this work has also gone into the BlackBerry 10 jQuery mobile theme that we announced at the keynote yesterday, and the BlackBerry 10 Sencha theme as well. So a lot of this work to build JavaScript and HTML and CSS versions of this is being reused in the other web runtimes. So we're going to show a little picture of what happens inside the browser application. I showed you the web views, but here's actually what's going on behind the scenes. So we have the web launcher. The web launcher is the multi-process launcher of the web platform that Matthew talked about. Basically, this is the only piece of native code. It's a very small script or executable on the device that actually runs and loads the first web view. So it starts, it creates the web view. The first web view is the main Chrome web view. We have an entry point that's index.html typically, although it is controllable. And the Chrome web view has those special permissions that we talked about. So it has native API access, and it has Webview API access. So you can see at the bottom there, it says qnix.callExtension method. This is a bound object in JavaScript that's available to the Chrome web views that allows it to call back out to the system. So it's just a JavaScript call, and it allows us to implement JavaScript native bindings. So we have a whole bunch of different bindings that are exposed, PPS for instance, and you call through qnix.callExtension method, you can get access to the PPS API. So you can create a PPS object and register for notifications when the PPS object is updated and write to it and all of this sort of thing. Or for invocation framework, you can send an invocation to the invocation framework, or you can get a list of invocation targets for a particular query, that sort of thing. The Chrome WebView has access to the Webview API, so it can actually create the other web views that are part of the browser Chrome. In this particular case, we're showing two, the navigation bar and the application menu. Those are in separate web views. And then there's an RPC channel that's set up between the various web views, and it's all built on top of a JavaScript eventing API. So it looks like pretty standard JavaScript that people are used to, a post event, on event type message port thing. And you can do some publish subscribe type messaging across there if you want, but it's pretty straightforward and looks pretty familiar to what you're used to if you've used the DOM eventing API, for instance. Now, all of those are in the Chrome process. Then, because we have a multi-process launcher, we actually start up a second process, the content process, and that is where the browser tabs go. So the browser tabs are created by the Chrome WebView and as out-of-process web views. And here we have BlackBerry.com and Starbucks.com and whatever, and they're sandboxed off. So if that process were to have any issues, then we can kill the process, and you get a screen inside the Chrome WebView that says there was a problem with your browser tab, and you can pick which ones you want to restore if you want to try restoring them, or you can restore none of them if you want. But that is all done in the Chrome process. So Matthew's now going to talk about the API examples, a little bit about the code to actually implement this.
Can you actually see that very well? It seems like that's kind of blurry. Anyway, the intention here was to show you sort of a basic example of what we're talking about when we say we want to spin off a web view, right? Because it sounds all great, but how do you do it if you're actually developing and you actually want to start using this process? So it's pretty easy in general. You don't actually need to worry about this stuff so much. This is just enabling Web Inspector. But I think the most interesting things come down here. So to create a web view, it's pretty simple. We just have a method called create. And you pass it sort of the root web view. And it will create it, and it will add it to the existing window group in the application. It's really easy. And then the more important part is when you get the result back. It's an asynchronous call. We're calling across different from JavaScript into native. So inside of WebKit, it will create the web view, and it will send an event back to you saying that a web view was created. When that web view is created, that's when it gets more fun, and you can start setting up your web view. You can give it a geometry, which you'll need to do, so whatever geometry you want it to be. You can set it visible, set it active, which gives it keyboard focus. And then you can add, what we have here is just calling load URL. So that can be any kind of content. This doesn't have to be a remote web page. This can be a local resource, for instance, an index.html, which can be your sort of root, which kicks off and starts doing other things as part of your application. Sorry? WebWorks has a slightly different API right now than the web platform does, but the intention is to have those two merge eventually so that they're the same. The same functionality exists in WebWorks. You can still do the same thing. You can have one web view and have it actually spawn another web view, but the API is slightly different at the moment.
It's mostly just a stripped down version of this one. Has slightly less functionality, but it has an asynchronous create. You can create Webviews and that sort of thing.
So this is all good. But one thing that was really important for us and is going to be really important going forward is to make sure that this whole kind of design philosophy that is extensible. It's not very good if you have to go and you have to create everything all the time for each different application. We want reusable components, things that we can provide potentially as sort of canned UX elements for developers, or developers can start building up their own and have them reusable by other people or by themselves. So an example of what we've done is using requires modules so that we can actually componentize all of our JavaScript. In this particular example, we're showing a progress bar. So instead of creating 20 different progress bars throughout the application for each download, for the main progress bar, for other activity indicators, we created a simple component which takes a div in a code fragment. So inside our HTML, we'll place a div, which is just basically a placeholder. And then the JavaScript, we can call create progress bar. You pass it that div, and you can see on the first line here, what we do is we add a class to it, which is just CSS, and restyles that to make it look like a progress bar. And then it will create a couple of other elements underneath it to actually implement the functionality. So if you look on the side here, you can kind of get an idea of what that expansion looks like. So we start out with just a basic div fragment, and then when you call create progress bar, it will inject new DOM elements and style them for you. So you don't have to go through and create these things all the time manually. You can have simple JavaScript APIs which go and are basically like factories, which will remorph your DOM to implement these components for you. It makes it really easy. Here we've exposed some API, which is particular to this object. So you can do, just like a normal standard programming, you can call functions like set progress or close, and those functions will act on the object, and in the case of close, might destroy the DOM element. So it kind of brings in standard design, standard programming philosophies that you might be used to if you program in Java or in native, but applies them to JavaScript and to DOM manipulation. You want to talk about optimizations?
Okay, so building a large web application is a somewhat difficult task, and we started this by prototyping it in kind of an obvious way, and then had to do some optimizations to get the kind of performance that we're getting. So we are building up some documentation about best practices, but these are some main ones that aren't that complicated, but we found were big gains. So progressive loading. One of the things that was difficult for us for a while was startup time. And it was because we had to create all these web views and we had the multiple processes and that sort of thing. So what we did is we created a tiered startup. And what it does is it loads the content that you need immediately in order to get to the new tab page with the frequency list of your bookmarks and history, plus the ability to type in a URL in what we call tier 1. And then other things like the application menu or the tab switcher are instantiated later on. And another one was native container scrolling. So this is something that has always been a pain point since the touch web became popular. That is, how do you take a container that is not the whole web page, either something like an overflow scrolling div or an iframe, and make it scroll natively? So we've always had native scrolling since BlackBerry 7, but it didn't always have exactly the native scrolling physics if you did a flick scroll. And what we've done is introduced some accelerated, what we call composited scrolling, and that makes an iframe or a div scrollable just like native scrolling on the main frame. And also we allow it to be over scrollable, so it bounces back at the end, and that's allowed us to make it feel native. And we've done this using some de facto web standards, even if they're not official W3C web standards. We'll talk about that a little bit more. Window animations, as I said. So one of the window animations that you've seen is if you click on the tab switcher button and it pops open all of the content and leaves the tab switcher behind, that actually moves the navigation bar and the content web views and the main Chrome web view all together. And that's just an API. So there's an API for taking a bunch of web views and doing an animation on all of them at once. It's a pretty straightforward API. Works kind of like a CSS transition, except is outside of just one web page. Of course, we minify all of our JavaScript, and we compile it all together and optimize it using Closure Compiler. These are standard web best practices, and we found that they also gave us quite a gain on this style of web application. There are some limitations that we've run into with this platform. So there are still times where going to native can gain you certain things, although we certainly haven't found them insurmountable because we built the application, we're going to ship it, and we think it's pretty good. So one of the big ones is animating block height. This is a pain point in a lot of UI frameworks where if you want to take an element that's in flow, so say a div, and you want to make a transition on it such that it modifies the rest of the content, like pushing down everything below it, the relaying out of the other components makes it very difficult to do this at 60 frames per second. So right now we don't have a good solution for this. We kind of just snap open blocks and then we can do an animation within that. That isn't exactly what Cascades does. It can actually do a frame-by-frame animated increase in height. But we think that it looks pretty good anyway. Although if anybody has any good ideas about how to solve that, come talk to me later. Performance, so fundamentally, it's not so much that the web has better or worse performance than native, but the performance profile is definitely much different. So fundamentally, the web is single-threaded. That means that the main web thread has to do HTML parsing, it has to do CSS parsing, it has to do JavaScript evaluation, and it has to do rendering and painting. And web standards are built in such a way that most of those things cannot be moved to another thread in a way that really gains you that much. HTML parsing aside, perhaps there's some work there on moving that to another thread. But in general, like calculating the style of a page based on a change in CSS that was triggered from JavaScript modifying the DOM has to happen in sequence. So that means that certain operations you have to be careful that doing expensive DOM operations all the time, for instance, can make it so that you don't have content ready when you need to render it. That's where you end up with checkerboarding. So the tooling in Web Inspector, the timeline view, gives you a very good sense of what's going on that one thread that is required to implement the web. And a third piece is efficient large data transfers. So I showed you multiple web views with an RPC channel. And right now, there isn't a good way to get large amounts of data between the web views fast. So there isn't like this concept of shared memory that you might have if you just had threads in native that allows you to just send a small message and get access to big pieces of data. We've worked around that by trying not to transfer large amounts of data between web views and keeping most of the large data in the main Chrome web view, but it is a limitation to keep in your mind. And there are some times where we cheated. So unlike you guys, while we were developing this, we had access to the WebKit team and we could make them make changes on the native side. Hopefully now those changes are useful to you if you need them. But there are a few things we've done that are slightly BlackBerry proprietary extensions of web technology to get exactly the Cascades type behavior. So one example is text overflow. The normal text overflow on the web supports only none, which just clips text if it runs outside of a container, or ellipsis, which turns it into the ellipsis symbol at the end of the container. The BlackBerry 10 style is that we have this opacity gradient fade, and we could have implemented that using a CSS mask, but that's relatively expensive to calculate, so we just made a new native type text overflow BlackBerry fade that gives you that opacity gradient fade, and made that a text overflow option. Another example is WebKit overflow scrolling. So this is a property not standardized, but de facto standard these days that was introduced by iOS 5. And they introduced the option WebKit overflow scrolling touch. And that was the way that you got native scrolling on a subframe or on a div in iOS. Before that, they only had their 2-finger scrolling. So we also allow you to use WebKit overflow scrolling touch if you want. And that gets you basically like the kinetics of the default native scrolling. We key off the same value as them so that content is compatible. But we've introduced a new value as well called -BlackBerry -touch, and that gets you the overscrolling. So that forces the ability to overscroll. And that's, again, because of the cascades behavior, where if you have content in a vertically scrollable list that fits within the container on the screen, it's not scrollable, but it's still scrollable. That's that behavior. Another example is the data BlackBerry end selection on touch attribute. So this is something you can put on an input field. And what that does is if you have text in an input field and it has a selection, so they've long pressed on the text and moved the text selection handles perhaps, normally if you touch that, you get the crosscut menu and it allows you to like cut and paste. But the default behavior, or the behavior that we wanted on the navigation bar, was rather than the crosscut menu coming out, that actually dismisses the selection. So that is what that attribute does. But I wouldn't anticipate really that anybody wants to use these directly, even though you can, it's in the engine. If you were using any of our web implementations of the core components, then it might do some of this internally. But it's there if you want it. So development tooling was very important to us. We were developing a large new application, and we used a number of different things. Web Inspector is definitely the most important piece. If you haven't used Web Inspector, you should. If you want to learn more about Web Inspector, there's a talk in the next time slot, JAM 27, and you should go listen to Conrad tell you all about Web Inspector. But basically, this gives you DOM inspection and modification, gives you JavaScript debugging and profiling, CSS selector profiling, a timeline view of what's going on inside the engine, gives you a JavaScript console, and it's basically the most efficient way to work. So have your content running on the device and use the Web Inspector. It works remotely, so the actual console is available on your desktop or on your laptop, even though the engine's running on the device. Then we use CSS lint and JS hint. These are basically syntax checkers, and they look for some bad practices in JavaScript and CSS. We run these on commit so that we can catch potential issues before somebody actually runs it on a device. So this is very helpful to us. We have a unit testing framework. It's based on Jasmine. So Jasmine is a pretty popular, maybe the most popular web-based unit testing framework. It allows you to do asynchronous unit testing, event-based, which is very helpful when all of your APIs are asynchronous and event-based. We use Ripple. So Ripple is the BlackBerry web emulator. Runs as a Chrome extension. It gives you like the device skin with API emulation and like the correct resolution and that sort of thing. So we use Ripple in the early stages a fair amount in order to get the controls looking good, because it's much faster to run on your desktop where you have crazy powerful computers and very fast refresh times. So we did some of that early work in Ripple. And we use Node. So Node is a JavaScript runtime environment. It's often used for server-side applications these days, but because the whole web application is built using JavaScript, it made sense that we also built all of our tooling, like our build system and that sort of thing, in JavaScript as well. And when we run that on your desktop, when you're compiling the application, we run all of that JavaScript inside of Node. Also, Node plugs into Ripple in order to do building of BlackBerry applications. We also have some workflow that we sorted out that worked nicely for us. So I've talked about our build system a little bit. We talked about closure compiler and minifying and concatenating together all of your assets. So you saw the plugin modules that Matthew described, where we're using the require.js style. And we have a build system that takes those and compiles them together in a more efficient way at runtime. We also have a lot in the build system about running pretty aggressive checks about CSS and JavaScript and making sure things work. And the build system is something that we spent a lot of time early on so that we could make sure that our development flow was much smoother. Often the build system is kind of an afterthought at the end, but we found that spending the time there early really paid off. We have this Chrome URL environment variable. So we talked about the web launcher that's part of Web Platform. The way that it decides where the first page is it looks for this environment variable called Chrome URL. So a nice trick that you can do, normally the Chrome URL would point at an asset that was packaged up in your bar file or in your application on the disk. But while you're developing, what we actually would do is point the Chrome URL back at your desktop or your laptop, run a web server there, and host the content on your desktop. So the only thing actually running on the device was the launcher shell, the native piece, and all the web assets were pulled from the device. And as long as you have a fast connection between the device and your development machine, the USB net connection is what most of us were using, although if you have fast Wi-Fi, that probably works too. And that means that it's really easy to just change stuff on the server side and reload. You can actually use Web Inspector to force it to reload as well, so you don't even have to rerun the binary. And then we have a lot of Git pre-commit hooks. So we use Git as our version control system. And we have pre-commit hooks that do style checking. We have pre-commit hooks that run JS hint and CSS lint and do syntax checking. We have pre-commit hooks that run spell checking. We have pre-commit hooks that check to make sure that your code got reviewed. So if you don't fill in who the reviewer is, it rejects the commit. But we're very aggressive on not letting people check things in until they pass a lot of tests. And that means that our code quality actually got much higher when we started to do this. We started seeing way less regressions and that sort of thing. So as a lot more people came on board, the early versions of the browser were prototyped by just a few people, but as we built up the team, this really allowed us to maintain code quality as we scaled that up. So what did we learn? We learned that it's possible to do this. Great looking, high performance web applications are possible on BlackBerry. And we learned that there are still some gaps. There are some gaps in the open web platform, that is, the standards that work cross-platform. And the way to solve those properly is definitely to push them in the standards process. So that's certainly something that we're involved in. And there's a number of groups at the W3C who are working on standardizing some of the things that you might want for this type of application across platform. And what's happening in the future? We want everybody to develop web applications like this. So not every web application has to be this complicated. Not every web application needs to have out-of-process web views. But certainly we would like, and we think that people want to build, and we've heard feedback that people want to build more of this type of application. So we're bringing a lot of this technology to WebWorks in future releases. You're going to see a lot more prepackaged components and the ability to run out of process and that sort of thing. And of course, we're always working on WebKit. So performance is always the #1 feature, but HTML5 API coverage and all of that is something we're pushing very aggressively. You saw our HTML5 test score yesterday and that sort of thing. So we're definitely keeping on the cutting edge of new web technologies as they emerge. And as the open web platform evolves, we're going to help make sure that all of this stuff works across platforms. So the open web is the open web. We don't want this to be a BlackBerry proprietary web that's better than some other web that is available on other devices. So we're working a lot in open source. All of our code gets contributed back to WebKit when we work on core engine things. And we're working on this in standards to make sure that this stuff all is available everywhere. So if you want to talk more about this, Matthew and I will be at the Ask the Experts roundtable session at noon. And you can come ask us your hard questions that I didn't cover. And on Twitter, if you want to talk about this, use the hashtag BBJam and our session ID. Don't forget to download the mobile conference app. That is a web app, by the way. And go to the 10,000 Reasons to Believe booth in the Jam space and record your videos and get out there on the internet. Thanks, everybody. And I think we might have a little time for questions.
Okay. So I think we have about 10, 15 minutes for questions. I know it's a pretty big topic to go through all of this. So it's kind of a big, high-level overview of what we've done. But certainly if you guys have questions now, we do have 10 minutes, or you can come and see us at the roundtables for more in-depth questioning, and we can give you much more detail in that venue. So.
I know Stefan raised his hand earlier.
Yeah, sorry, do you mind your recording and then
So, how big is your team when you scaled it up to full size?
How big is the whole web team or the browser application team?
Just answer the question.
What's that?
How big is the team that commits?
OK, so for the browser application itself, our team was relatively small. It was on the order of 10, probably around 10 to 15 people writing CSS and JavaScript. But I don't think that's probably really a fair look at how we did this, because there was a whole evolution of the web platform as well, and the improvement on WebKit. And our whole WebKit team is significantly larger than that.
Is there a way to hide the navigation bar, like using some kind of meta tag or something, so that the web view can take the full screen?
So we do support add to home screen bookmarks that have the mobile web app capable meta tag that will launch Chromeless. But for just navigating to a website in the browser, there is not a way to hide the navigation bar.
Like, can you swipe down, or like on the playbook you can swipe
Right.
up?
At the moment, no. There are a number of reasons for that. I think our main one is security and making sure that we do it in the right way, especially since in this particular case, the URL bar is at the bottom. In the case of Playbook, the URL bar is at the top, so we still had Chrome that could be attached there so that we could prevent from phishing and other types of Chrome emulation attacks. In this case, it's a bit different because our URL bar is at the bottom. So I'm not going to say it's not something that we're not exploring, but we want to make sure that if we implement it in the correct way. And a standard, nice way, so it's not something ideally proprietary.
On a related note, we do support the HTML5 full screen API. So for things like media, you can go full screen. But of course, we have to prompt the user to let them know that that's happening, because otherwise we expose ourselves to pretty obvious phishing attacks now, especially because we've implemented the Chrome in web. So it is clearly possible for somebody to, on their website, implement something that looks exactly like the Chrome.
On the peak portion functionality on the web browser, can you switch to a left-hander and do it the other side? You know how you slide with your right thumb?
Is that particularly the peak about the tab bar, or peeking back?
The tab, just peeking into the
Right.
other side?
So we haven't implemented a mirrored UI at this point. It is a consideration, especially for languages that require, for instance, a true right-to-left user
just
interface.
odd for left-handers to.
Right. So there's no fundamental limitation to say we can't do that.
Okay.
But in the browser application right now, it's only implemented in the one way, the
Okay,
one
thank
direction.
you.
I think it would make sense to do something like that on a system-wide basis. And right now, there isn't a system-wide way of doing left-hand English.
Hi. It might seem like a little thing, but apparently it keeps coming up, and that's the browser bookmark issue. And I've talked to a lot of people that really have a lot of bookmarks and may want to organize them into different folders. And it's obvious that the tags and filters will give you quick access to it. I know on my BlackBerry, I search by alpha because the list will, as I start typing, I hit B, K, and then I start typing the shortcut, and it'll take me right to it. So I don't organize them on my BlackBerry. But on my Playbook, I've got tons of bookmarks, and I have absolutely no way of accessing them that quickly without scrolling a lot. Is that information going to be made available through an API, or is there a way to access that information so that, say, if it's not going to be in the native browser, that maybe a third-party app could be written that would be able to access and reorganize that information?
The bookmarks?
Yes.
We don't currently have an extension API to build a third-party application that has access to browser data. Although certainly bookmarks are connected to the enterprise management solution. So for enterprise users, certainly they can provision bookmarks and that sort of thing, which allows bookmark management. But definitely we heard a lot of feedback from Playbook users that managing bookmarks on Playbook was not the most pleasant experience. And that's why we introduced searching and tagging.
I mean, it's integrated. We have the ability to do it. It's integrated into search, for instance. But we don't have a proper API for third parties to do that. Out of curiosity, how many bookmarks are you talking about here?
Me personally, I've probably got 40 some odd. I know people that have way more than I do.
So, and your pain point was mostly on Playbook?
Predominantly, yeah. Is
Okay.
the alpha search on, because you don't even have that option.
Yeah, exactly,
to
yeah.
do an
So I'd be
alpha
curious
search
to
on
see
the
how
Playbook.
that experience translates over to BB10 if you use tags or if you use the search that we have,
Yeah.
if it becomes easier.
Yeah, I can imagine. I'm thinking of people who may, have several different groups of bookmarks that they want to group together, and maybe can't remember them all the time. So,
Right.
but it's a possibility.
I mean, that's kind of the point of tags.
That's
Yeah. So okay, that makes more sense. to
tags
me.
is kind of like a different way of looking at it. I mean, it's kind of like folders without actually putting them in folders because they can be in multiple folders
Kinda
depending
like
on the tags.
Google labels.
So,
Sort of.
yeah.
I had one more question. How about on the BlackBerry, you can hit T to go to the top of a page, B to go to the bottom of the page. Is there a top and bottom function in the BB10 browser? Because the Playbook one does not have it.
At the moment, no.
Can we request one?
We're actually looking at more interesting ways to do it rather than using shortcut keys, because shortcut keys can cause problems on pages that have key event listeners, key event handlers. So we'd rather do it in a different way, and we do have some ideas on that, but it's not implemented at this time.
But you are thinking about it, and
Yeah.
that's good.
Yeah.
That's all we want.
It's a problem, right? Long pages, you need to be able to scroll quickly, right? We want to make it easy for users to use the web, so it's definitely on our radar.
So this one is actually a very, very simple, non-technical question, and more just out of curiosity. With the alpha device that we've been using, bookmarking to home screen still has the limitations that BB7 has, from my understanding, or from what I can tell, about not being able to select your bookmark image. So when you bookmark it to your home screen, you can't select a custom image for it. You just kind of get some random screenshot of the center of the page. iOS does allow you to do that, and the feedback that we've received and some of the things that we do is that's one of the best things about the browser on their standpoint. Is that something that is planned to take place as well?
So we don't intend to, or we don't currently have a plan to make a user choosable way of deciding what the icon is, but certainly we will support the Apple Touch icon meta tag, so the site can decide what the icon is on the home screen bookmark.
Okay.
Which is exactly what iOS does.
Thank you.
I think we have time for one or two questions more, if anyone has any.
Okay. Thank you all for coming, and feel free to come by and talk to us later.